So yes, so we are going to discuss today how to calculate the practical methods for investigating the rate of reaction. Okay, like according to the syllabus, they are saying describe and evaluate practical methods for investigating the rate of reaction, including the change in mass of a reactant or a product and the formation of a gas. Okay, so obviously we have to consider any type of experiment you can say. Okay, so this is the thing that we are going to do: experiment to determine the rate of reaction. They have mentioned in the syllabus that you can just consider the loss in mass, okay, or you can say in terms of gas. So I have taken this conical flask, okay, and then I have sandstone in this, okay, and then just I have added dilute hydrochloric acid, okay. It's a marble chips, let's suppose, okay. Let's suppose it's calcium carbonate, right? So calcium carbonate, when reacts with this acid HCl, right now so far I'm telling you that it's going to you can say it's going to produce carbon dioxide. It's going to produce what? Carbon dioxide. If you can see the bubbles. Okay, let's suppose so far we are considering this. So the gas is removed. So the gas is removed. Let's suppose right now I have this mass that is 94.02 grams. But when the gas is released, so the mass is this 94.00. This much mass of the gas is decreased. Okay, this is the change in mass. This is the change in mass. Now you can just turn on your stopwatch. You can turn on your stopwatch and then just you can see how much the time it's going to take to decrease the mass by 0.02 grams. Okay, it's taking 2 seconds, it's taking 4 seconds, it's taking 6 seconds, it's taking 1 minute, it's taking 2 minutes, it's taking 10 minutes. So basically it's going to tell you the speed of reaction. If it's taking less time, so you can say that the rate of reaction is faster. And if it's taking larger time, the greater time, then you can say that the rate of reaction is slower. So this is the, like, whenever we are going to determine the rate of reaction, we always consider the reaction and experiment in this manner. You will always see the loss in mass or gain in mass. Right now, we are just considering the loss in mass. If the mass is being lost in a limited amount of time, in a short of time, so I can say that the rate of reaction is faster. But if the loss in mass is taking so much time, let's suppose I have it's like it has taken like 5 minutes to decrease by mass by 0.02 grams. Obviously, this is taking so much time. So I can say that the rate of reaction is slower. Obviously, I can say that the rate of reaction is slower. So this is an experiment by which we can determine, like how the rate of reaction is. It's very fast or it's very slow. What if we would be dealing with gas? What if we would be dealing with gas just like that? If you can
AirPods
see,
देखे मेरे?
sorry,
ये वाला नहीं
Faryal,
दूसरा. ये है मेरे लेकिन दूसरा.
Faryal. So let's suppose in this conical flask, okay, again the same thing. Calcium carbonate is going to react with HCl. It's going to produce carbon dioxide. So the gas is released just like that. Or you can consider magnesium is going to react with HCl. It's going to produce hydrogen gas. So obviously you will see hydrogen gas. So hydrogen gas is collected into this syringe. Okay, hydrogen gas is collected into this syringe. Then just you have turned on your stopwatch. Okay, and then just you can see this, that your syringe is of 5 cm cube in total. The volume of this syringe is total 5 cm cube. So 2 cm cube gas is collected in half minute. Okay, 2 cm cube of gas is collected in half minute. And then you did another experiment. Then you did another experiment in which you saw that 5 cm cube gas is collected in half minute. So now you can decide, you can decide, you can assess, you can examine, like this is faster, okay, and this is slower. This is slower. So basically, if you are going to have maximum amount of gas in a limited amount of time, so the reaction is faster. And if you can see, you are going to have less amount of gas in the same time. So you can say that the rate of reaction is slower. So the rate of reaction is slower. Okay. So this is very important thing to know. This is very important thing to know. Okay. How the rate of reaction is going to be determined. Okay. Now, let's suppose I can tell you, I'm just doing the same experiment. I'm just doing the same experiment. I have taken this conical flask. Okay, I have just taken this conical flask. I have just added magnesium and HCl. It produces magnesium chloride and hydrogen gas. Okay. I have just turned on my stopwatch. Okay. I have just turned on my stopwatch. So let's suppose this is volume of hydrogen gas and this is the time. Let's suppose 2 seconds has passed. I just got the volume that was 0.1 centimeter cube. Then just 4 seconds passed. Then just I saw I got 0.45 cm cube volume. Then 6 seconds have passed. Then I just got to know that I got 0.6 cm cube of volume of hydrogen gas. Then after 8 seconds, I saw that I got 0.8 cm cube volume. This is the data, let's suppose. This is the data like that. Okay. After this experiment, I got this data after this experiment. Okay. So then what I am supposed to do with this data? What I am supposed to do with this data? So just look at this. You will be drawing the curve. You would be drawing the graph like that. You would be drawing the graph just like that. And you will be having this line. It may be like that. Okay. It may be like that. It may be like that. Depends on the data that you have. Depends on the data that you have. Okay. It depends on the data. Let's suppose right now, so far, I just got this line. Okay. I just got this line. What this line will tell you? Initially, this is more steeper. Initially, this is more steeper. Steep gradient at the start means that the reaction is faster. How? If you can see, the volume is changing so fast, but the time is not changing so fast. The change in volume is faster. The change in volume is faster. And when the line goes like that, if you can see, the time is changing so fast, but there is no change in volume. Let's suppose this is 0.8. So still this is 0.8, 0.8, 0.8, 0.8, 0.8, 0.8. The same thing you are getting. So obviously the rate of reaction is slower. I can say this is the less steeper line. When the line is going just like that, the line becomes less steeper. The less steeper, okay? When the line becomes less steeper, so you can say that the rate of reaction is slower. And when the line is more steeper, just like that, when the line is more steeper, so you can say that the rate of reaction is slower, okay? The rate of reaction is slower. And then when the line becomes straight, when the line becomes straight, so you can say that the volume is not going to change. The volume is not going to change. So hopefully the reaction has stopped. Hopefully the reaction has stopped. So this is the curve that would be telling you regarding the rate of reaction. But how you got this curve? Obviously, I would say that from the following data that I told you. So always examiner would be giving you the data and you would be drawing the curve, and then you have to decide how the rate of reaction is going on. Is that faster and is that slower? So remember, these are very important lines. If the line is more steeper, it means that the reaction is faster. And if the line is less steeper, here the line is less steeper. This is less steeper line. So less steeper means slower reaction. Okay, less steeper means slower reaction. More steeper means faster reaction. More steeper means faster reaction. Less steeper means slower reaction. When the line becomes straight, so the reaction has stopped. When the line becomes straight, so the reaction has stopped. So these are the main important points that you need to consider. Okay, let me solve some past papers, topical past papers related to this topic. So just wait. Yes, just see this question. Just see this question. Yes, this is the Feb March paper. Okay, so Igcse, the graph shows how the volume of carbon dioxide gas changes with time. Yes, describe how the graph shows that the rate of this reaction decreases as the time increases. Can anyone tell me? Yes. Ayat, Abdul Wase, Adan, Hamna, Huria, Maheen, Muhaimin, Qasim, Reni, and Rija. Can you tell me? Yes.
Can I answer?
Mhm.
Sir, the slope keeps getting more curved until it settles into a straight line.
Oh, okay. So I can say that like the gradient of the curve, like I can say that the line becomes less steeper. The line becomes less steeper. As you can see here, this is more steeper. Here, this is more steeper. This is the less steeper. This is the less steeper. This is straight. The reaction has stopped. Obviously, in the start, the reaction was faster. When the time has passed, so the reaction is going to be slower. So they are saying describe how the graph shows that the rate of this reaction decreases as the time increases. As the time increases. So you can see this. The line becomes less steeper. Line becomes less steeper. Gradient of the curve decreases. This is the reason the rate of reaction is going to decrease, right? Okay. Explain in terms of particles why the rate of this reaction decreases as the time increases. Can anyone tell me? This is very easy. This is very easy. Trust me. This is very easy regarding the number of particles. Yes. Can anyone tell me? Fast.
Less collisions as time increases.
Less collision. Less collision. But how can you say that there is a less collision? How can you say that? Yes.
So there will be less concentration of the reactants because the reactants will be used up in the reaction. So it will have less collision, which means the rate of reaction decreases.
Basically, you can say that. When the reaction has started, obviously, always we say that the concentration of reactant decreases and the concentration of product increases. So as the time is passed, okay, so I can say that the concentration of the reactant particle in this question, what is the reactant? What is the reactant? Basically, I have given this question from the D part. So I'm telling you that in this question, basically the acid is going to react with metals. Like acid is going to react with the metal carbonate. It's going to release carbon dioxide. So you would be writing like, let's suppose you would be writing that amount of acid, or you can say concentration of acid decreases. Due to this, there is a less number of collision. There is a less number of collision between the particles. This is the reason rate of reaction is going to decrease. That's very easy. Okay. Now tell me this. Yes, the student repeats the experiment using powdered magnesium carbonate instead of the large pieces. All other conditions stay the same on the grid. Draw the line expected when powdered magnesium carbonate is used instead of a large pieces. Can anyone tell me this? They are using powdered magnesium carbonate rather than the large pieces. So what would be the new line on the grid? What would be the new line on the grid? Can anyone tell me? Yes. This is very easy.
Sir, can I answer?
Yes. Ayat?
Sir, the slope will be a little bit more beneath. The rate of reaction will be faster.
Okay, the rate of reaction will be faster.
The line will be more steeper.
The line will be more steeper. Okay, exactly. Great, good. So I can say that the line should be just like that. Yes, Hamna, excellent. It would be just like that. Would be just like that. Just like that. Okay. This line shows that the line is more steeper, means the reaction is faster. But remember, faster and slower, it doesn't mean that you would be changing the number of particles. The amount of product will remain the same. But the reaction becomes faster. So you will see the line becomes more steeper. That's it. Okay. This is very easy question. Can you tell me this? Can anyone tell me this? Yes. I'm going to give you few seconds. Yes, please. 30 seconds. Someone is saying 60 seconds, right? So remember,
30 seconds.
31 is correct. The 31 is correct. Time taken is like they are saying what? Basically, a student investigates the reaction of magnesium powder with dilute hydrochloric acid. The magnesium is in excess. Okay. The rate of reaction can be found by measuring the increase in volume of hydrogen with time. Okay. The results are shown on the graph. Okay. So now the reaction becomes like line becomes straight. I can say that the reaction has been stopped. The reaction has been stopped according to the concept that I have told you. Reduce the time taken for the reaction to finish. Reduce the time taken for the reaction to finish. Okay. So exclusively, I can say that over here, when the line started to become straight. So this was the time, that was 30. Exactly. Yes. This is 30 seconds. Now, how can you say regarding B? Like what it should be? Yes. Mm-hmm. Yes. Yes. What do you think regarding this? Mm-hmm.
The reaction is slower, so it will be shallower.
Reaction is lower. Okay. The experiment is repeated using dilute hydrochloric acid of a lower concentration. Okay. Draw a line on the grid to show how the volume of hydrogen changes with time using dilute. Dilute. Dilute means the less number of particles, means the less number of particles, means there is a less number of collision, means there is a less number of collision. Okay. So less number of collision means that the rate of reaction would be slower. So they are saying draw a line on the grid. Draw a line on the grid. So I would be drawing the line just like that. Just like that. Okay. It means that the rate of reaction is slower. The rate of reaction is slower. Okay. This is, I have just drawn the line less steeper. This is less steeper. This is less steeper. Okay. Are you getting my point? Anaika is here. Anaika. Okay. Okay. Easy, easy. Right? How can you make this? Can anyone tell me? Yes, Kasim and Rainy. Rainy, today you are silent. Why?
Sir, can you repeat the question?
Beta, see this. Complete the diagram to show the apparatus used to investigate the volume of carbon dioxide during this reaction. Produced during this reaction. Mm-hmm.
You'll use I'm not sure.
Okay, see this. See this. Uh-huh. Okay. 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 Then. Basically, these are the marble pieces. Like this is calcium carbonate plus HCl. I have added HCl over here. So obviously the carbon dioxide would be released just like that. And then I have collected the carbon dioxide in this beaker. Am I right?
Yes, sir.
Name the piece of apparatus labeled M in the diagram. Yes.
Sir,
Flask.
measuring cylinder.
Measuring
Is this what?
A measuring cylinder.
Exactly. This
Sir,
is
measuring
measuring
cylinder.
cylinder. Exactly. Exactly. This is a measuring cylinder, right? This is a measuring cylinder. Suggest the name of another piece of apparatus that can be used to measure the volume of carbon dioxide produced.
Gas syringe.
Exactly. Exactly. Gas syringe. This is gas syringe. Nice. Nice. Okay. Oh my God. See this. See this. You are supposed to draw this and then send it to the group. Fast. Fast, 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 fast. Right now. Fast. Right now. I want to see what you are going to draw. I want to see what you are going to draw, what you are thinking right now regarding this. If we are going to determine the rate of a reaction, but fast. Fast, fast, fast. Fast. Anaika, you are late. Fast, I'm waiting. Fast. Fast. You need to draw this and then send it to the group. Anyone, any one of you, any one of you. Yes, Adan, you can do this. Huria, you can do this. Qasim, Reni, Rija. Rija, where are you? You're not seeing something. Mohaimin, Hamna, Faryal, Anaika, Ayat Zubair. Yes. Waiting for you. I'm waiting for you. Are you going to draw this? I'm waiting. Are you going to draw this? Rija, can you tell me? Rija? Rija, can you tell me this? Yes,
sir,
Rija?
it will
Okay.
be connected to a conical flask with
Okay.
that has a cork on top of it.
Okay. So see this, I'm going to draw this. Just look at this. This is connected with the, you can say, this is connected with the conical flask. Okay. Oh my God. I want to duplicate this. Just like that.
Sir,
And
in
then,
this we will,
yes, yes.
sir, there will be conical flask, delivery tube, and gas syringe.
Exactly, yes. It should be airtight. No gas should be escaped. No gas should be escaped from this conical flask. Okay. I have calcium carbonate in this and just added HCl to that funnel. Okay. Then obviously the gas would be produced. Obviously the gas would be produced. Okay. And then it would be collected in the gas syringe. So in this way, we can determine the rate of reaction. That's it. It's very easy. It's very easy. It's very easy. Okay. Okay. That's all. That's all regarding the rate of reaction. That's all regarding the rate of reaction. You are supposed to solve more and more questions related to this. Okay. Hopefully, I have taken your test in the last week of energetics, like energy from chemicals, exothermic reaction and endothermic reaction. So those who has got the less marks, so I would be sending the retest, okay, on Wednesday. And those who has got
I didn't
good
do
numbers,
the test.
okay, Fatma, text me after the class, okay?
Okay.
And then those who got good marks, more than 50 marks, more than 60 marks, they are supposed to do the next test. That would be on the rate of reaction. Okay. So let me tell you some more questions regarding this. Um, can you tell me this? Can you tell me this? Yes, this equation. This question is about compounds containing chlorine. The equation shows the reaction of aqueous methanol with hydrochloric acid. The progress of this reaction can be followed by taking small samples of the reaction mixture every hour and determining the concentration of hydrochloric acid. Describe a practical method by which the concentration of hydrochloric acid can be determined in a sample. Can be determined in a sample. Yes, this is very easy. I'm giving you just few seconds. You are supposed to just think, and then I would be asking that what you are supposed to do with this question, but fast. Obviously, I'm telling you, obviously, but you have to think by yourself first. So few students are new, so I'm not supposed to ask the difficult question first. So do this first, and then inshallah we would be heading towards that question. Just fast. Yes. Yes, 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 yes. Mm-hmm.
Can I answer the first one?
Why not?
Okay, so for the first one, as the
Mm-hmm.
temperature is increased, the particles collisions increase, and the energy is above activation energy, so the reaction is increased, the rate of reaction.
Nice. Great. Excellent. Yes.
Sir, can
So
I
the
answer?
same answer. Yes, why not, Hamna?
Sir, it is because like the rate of reaction increases due to more frequent and energetic collisions between the
Exactly.
particles.
Exactly. So basically, when you are going to increase the temperature, obviously the particles would be moving more faster as they are gaining more kinetic energy. So they would be having a more successful collision. So they would be having a more successful collision. So that's why I can say that the rate of reaction is going to increase. Now check this. Yes. Easy, easy. The reaction is repeated using a higher concentration of hydrochloric acid. All other conditions stay the same. Describe how the rate of reaction changes I want to ask from Abdul Wase. Yes, Abdul Wase, can you tell me? Abdul Wase, fast, easy.
Yes, sir. The
Okay.
as the concentration of the hydrochloric acid increases, there will be more collision.
Okay, there will be more collision, and
Because
then
there will be more particles in when the concentration is increased, so the rate of the reaction will increase.
exactly, the rate of reaction is going to increase because the reaction is repeated using a higher concentration. Higher concentration means the more particles. More particles means the more collision. More particle means the more collision. When you have the more collision, obviously there is a maximum probability to have a successful collision. So when there is a successful collision, so obviously I can say that the rate of reaction increases. Mohaimin, are you getting my point? Yes or no? Is that easy for you or no? Yes.
Yes, sir.
Good. Good. Uh, can you tell me this question? Can you tell me this? And I'm asking from Maheen. Maheen, are you late today? Maheen? No?
No, sir.
Okay. Oh, can you tell me this? They are asking state how long it takes from the start of the experiment to collect 18 cm cube of hydrogen gas. Yes. It's baby question. It's baby question. Easy question.
6 minutes.
6
10
minutes. But
minutes.
10 minutes. Oh my god. 6 to 10. Okay, let me check this. They are saying 18 cm cube of hydrogen gas. How long it takes from the start of the experiment to collect 18 cm cube? So this is 20 and this should be 11, 12, 13, 14, 15, 16, 17, 18. So 18 and then this is the time. 5, 6, 7. Oh my god, I should draw this line. So this is 11, 12, 13, 14, 15, 16, 17, 18. This is 18 cm cube. Okay. And this is the time. So if you can see this, 4 to 8, the difference is 4. And how many boxes you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So means that it should be 5, it should be 6, it should be 7. Am I right? Yes or wrong? Am I right or wrong? It's 5, it's 6. No. Yes. Each box is of what? Like this is 0 to 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes you have. 10 boxes you have. Can anyone tell me? Yes, Madarka, you are so late today. Madarka, you are so late. Why?
Sir, I was like doing past papers. I have got some.
Okay. Rija, where are you, Rija? Can you tell me this, Rija? Yes, it should be in between. Yes, 4 to 8. Like the 4 to 8 means it should be 6. Obviously, around 6. Right? Yes or
Yes,
no?
sir.
Okay. So when you are going to have 18 cm cube of hydrogen gas, so it would be taking this much time. It would be taking this much time. So this is very easy to determine the time and the volume by just using the curve. This is very easy. This is very easy. Okay, and these type of questions, that they are very easy, like describe and explain using ideas about collisions between the particles, how the rate of reaction changes when the large pieces of iron are used instead of the powder. When the large pieces you are going to have, it's mean more surface area. It's mean more surface area, or I can say the less surface area. Can anyone tell me? Yes, more surface area or the less surface area? Yes. Can anyone tell me?
More.
So more means the rate of reaction would be slower or the faster.
Faster.
They are saying, see this question.
No, slower,
How-
slower.
Slower, exactly. They are using the large pieces. They are using the large pieces of iron instead of the powder. Okay. So obviously the rate of reaction would decrease. Okay.